everyone, so welcome back to my new video. So myself, I'm Santosh Morar, currently pursuing my engineering in Sri Venkateswara College of Engineering. So today I'm back with a new topic called electromagnetic theory. In that, a small concept. So let us dive into the topic. So the topic is Gauss law and its applications. So, introduction to Gauss law. So, what is Gauss law? A Gauss law is a fundamental principle in physics that relates the electric flux through a closed surface to the total charge enclosed by that surface. So, this is the definition of the Gauss law. So, it is based on the concept that the total electric flux or field passing through a closed surface is proportional to the total charge inside the surface. And the Gauss law is derived from Maxwell equations and is essential for understanding the distribution of electric fields. So the Gauss law equation. So the mathematical representation of Gauss law is integration of E dot dA is equal to Q by epsilon naught, where E is the electric field and dA is the differential area vector and Q is the total charge enclosed and epsilon naught is the permittivity of the free space. So this equation quantifies the relationship between the electric field and the change distribution within the enclosed surface. And the Gauss law is applicable to various geometries and charge distributions, enabling the calculation of electric fields in a complex system. And here, this side, the figure shows the how the equation is formed, like Gauss law equation is formed. And then applications of Gauss law in symmetric case. So Gauss law is particularly useful in solving problems with high symmetry, such as spherical, cylinder, and planar geometries. By choosing a Gaussian surface that matches the symmetry of the charge distribution, the calculation of electric fields becomes more straightforward. Symmetric cases allow for the simplification of integrals and provide elegant solutions to complex electric field problems. So here are the applications of Gauss law, the determination of electric field. So spherical symmetry and cylindrical symmetry and planar symmetry. And there are equations too. So when it is spherical symmetry, the equation is E is equal to Q by 4 pi epsilon naught R square. When it is cylindrical, then it is lambda divided by 2 pi epsilon naught R. And when it is in planar symmetry, then E is equal to alpha 2 by epsilon naught. Then Gaussian surface. So what is it? A Gaussian surface is an imaginary closed surface used to apply Gauss law for calculating electric fields. And the choice of Gaussian surface depends on the symmetry of the charge distribution and simplifies the calculation of electric flux. And then finally, the electric field is assumed to be constant over the Gaussian surface, facilitating the application of Gauss law. And then electric field of a point charge. So what is it? A Gauss law can be used to derive the electric field of a point charge by considering a spherical Gaussian surface around the charge. Okay. Then the electric field is found to be E is equal to kq divided by r square, where k is the Coulomb constant and q is the charge and the r is the distance between the charge. So this resultant demonstrates the inverse square relationship between the electric field and the distance from a point charge. And then electric field of a uniform charge sphere. So Gauss law can be applied to determine the electric field inside and outside a uniform charge sphere. Okay. So by selecting a Gaussian surface that encloses the sphere, the electric field can be calculated using the total charge enclosed. And finally, the electric field inside the sphere is proportional to the distance from the center, while outside the sphere, it behaves as a point charge. And then electric field of an infinite line charge. So Gauss law can be used to find the electric field surrounding an infinite line of the line charge by choosing a cylindrical Gaussian surface, and where the electric field is found to be E is equal to lambda divided by 2 pi epsilon naught r, where lambda is the linear charge density and r is the distance from the linear line of charge. And this result illustrates the relationship between the electric field and the charge distribution along an infinite line. And then electric field of a charged plane. So Gauss law can be applied to determine the electric field near a uniform charge plane by selecting a Gaussian surface parallel to the plane. And then the electric field is found to be E is equal to alpha divided by 2 pi 2 epsilon naught, where alpha is the surface charge density. This result shows that the electric field near a charged plane is constant and independent of the distance from the plane. And then Gauss law in different form. So Gauss law can also be expressed in differential form using the divergence operator. So that is delta dot E is equal to rho by epsilon naught, where delta is the divergence operator, E is the electric field, and rho is the charge density, and epsilon naught is the permittivity of free space. This differential form relates the divergence of the electric field to the charge density at a given point in a space. And then finally, the differential form of Gauss law essential for analyzing electric fields in continuous charge distribution. And then Gauss law in integral form. So Gauss law in integral form states that integral of E dot dA that is equal to integral rho dv by epsilon naught, where E is the electric field and dA is the differential area of vector, and where rho is the charge density, and finally V is the volume enclosed by the surface. And this integral form relates the total electric flux through a closed surface to the total charge enclosed within that surface. Okay. And then finally, the integral form of Gauss law is powerful tool for calculating electric field in three-dimensional charge distribution. And then Gauss law and electrostatic shielding. So Gauss law plays a crucial role in understanding electrostatic shielding, where the conducting surfaces can redistribute charges to neutralize the electric field inside a closed cavity. And by applying Gauss law, it can be shown that the electric field inside a conductor in electrostatic equilibrium is zero. And then electrostatic shielding demonstrates the ability of conductors to protect sensitive equipment from external electric fields. And then a difference between Gauss law and Coulomb's law. So Gauss law and Coulomb's law are closely related concepts that describe the behavior of electric field due to charges, while Coulomb's law provides the direct relationship between charges and electric fields. Gauss law offers more general approach to calculating electric field using a charge distribution. And both laws are fundamental in electrostatics, are essential for understanding the principle of electricity and magnetism. And Gauss law and charge conservation. So Gauss law is a consistent with the principle of charge conservation, which states that the total charge in a closed system remains constant over time. By applying Gauss law to be closed surfaces enclosing charge distribution, the total electric flux can be related to the total charge inside the surface. And finally, the charge conservation and Gauss law are fundamental principles in electromagnetism that govern the behavior of electric fields and charge distributions. And Gauss law in electromagnetic theory. Gauss law is one of the four Maxwell's equations that form the foundation of classic electromagnetism. Together with the Gauss law for magnetism, Faraday's law of electromagnetic induction, and Ampere's law with a Maxwell's addition, Gauss law completes the set of equations describing behavior of electric and magnetic fields. And finally, the integration of Gauss law into electromagnetic theory enables the understanding of various phenomena, including the electromagnetic waves and radiation. And then finally, conclusion about the Gauss law is Gauss law is a fundamental principle in physics that relates the electric flux through a closed surface to the total charge enclosed by the surface. So this is the basic definition that we have discussed in the beginning of the video, and it enables the calculation of electric fields in complex charge distribution and symmetric geometries. And by understanding and applying Gauss law, physicists and engineers can analyze and predict the behavior of electric fields in a wide range of systems. So this is about the topic, and thank you for watching the video. Thank you.